Okay, exercise 14F, using counting in probability. No new content for this lesson. It's all about using the previous 4 lessons knowledge that's, you've learned a permutation, you've learned a combination. Now we're going to use this to help us to do the probability question. So I actually picked 4 questions from the exercise, and I'm going to go through these 4 exercises, and that should be enough for to cover this lesson. So let's have a look at the first question here. The first question says the letter promise arrange randomly in a row, find a probability that the word starts with R and ends with S. Alright, so it's actually pretty interesting and an easy question here, to be honest, alright, because it's about the same, okay? Instead of a question asking you about arrangement, you're actually asking about the probability, the chance. So the first step we do is we need to find out the total arrangement when there is no restriction. So the idea about this exercise is we find what happened to the arrangement when there is no restriction. Okay, so we just count 1, 2, 3, 4, 5, 6, 7. We've got 7 letters and they're all different. So the total arrangement is just 7 factorial. Once we have finished that, then what we need to do is we look at each of the restriction questions here, and then we find the arrangement for each of the restriction, and then we just divide by divide this arrangement by the total arrangement when there is no restrictions. In that case, that's it. All right, and you get the probability. So that's the idea how you actually do the question. All right, so the second question says, I'm going to start with the letter R and end with the letter S. So therefore, we have R and S fixed. All right, what's inside is 5 letters where you can rearrange those 5 letters. So therefore, the arrangement here is 5 factorial. All right, so in that case, the answer here is just equals to 5 factorial over 7 factorial. That would be the actual probability. Okay, so therefore that's 5 factorial over 7 times by 6 times by 5 factorial. And if you cancel these 2 out, the answer is pretty easy. It's 1 over 42 chances. Okay, so that's question A. Alright, so now for question B. The letter P and R are next to one another. Okay, so what we need to do here is we need to group the letter P and R. Okay, so we're going to group P and R together. That's one group. And we'll have 1, 2, 3, 4, 5. 5 letters left. Okay, so therefore within these 5 letters, within these 6 groups here, so that's 6 factorial ways of rearranging it. And then you can rearrange P and R, so therefore that's 2 factorial. Alright, so therefore the probability will be 6 factorial times by 2 factorial over 7 factorial. And that's pretty easy to simplify. 6 factorial times by 2 over 7 times by 6 factorial. So without using calculator, you can even just do the calculation very easily if you know how to enroll the factorial. So that's 2 out of 7. Alright, next one, question C. Let's have a look what's question C. The letter P and R are separated by at least 3 letters. Separated by at least 3 letters. Now, how would you do this one here? At least 3. So we need to find the total possible ways where letter P and R are actually separated by at least 3 letters. So we can have like 3 letters, we can have 4 letters, we can have 5 letters. Okay, so that's the that's the idea. Okay, so what we need to do is there are several ways you can do that. P and R are separated by at least 3 letters. So let's try this method here. Okay, so we've got like a 1, 2, 3, 4, 5. Okay, 5 letters here. Now let's just place the P at this point. Okay, so if you place the P at this point here, then let's have a look what how many arrangements are possible. But firstly, let's rearrange all these 5 letters. That's 5 factorials. Okay, then let's just count how many ways you can place that P and R, where P and R is separated by at least 3 letters. So at least 3 letters. So that will be the R here. Okay, so that's R. Obviously that's 3 letters in between. Then we can also place an R here, where that just means we have 4 letters in between. So we can keep going and we can place an R here. So in that case, we have how many positions? When P is at this point, we have 1, 2, 3. So we've got 3 ways of that. So we times by 3 plus. Now you can move the P to the position here, and then count where's the position for the R. So when you move the P one place to the right, then you've got 1 and 2 position to have the R. Okay, and then you can keep moving the P one more place, and then in that case, you have only one place to place the R. Okay, now I think we need to times by 2 again, because remember the P and R can be switched around as well. So you can have an R here at the front instead of P at the front. Okay, so if we times by 2, that should give us the arrangement, the total arrangement when P and R is actually separated by at least 3 spaces. Okay, or 3 letters. So that gives us 5 factorial times by 3 plus 2 plus 1 times by 2 over 7 factorial. Okay, so let's have a look at what is that equals to. Just using the calculator and work out the answer. Alright, after calculation, so that the answer is equal to 2 out of 7. Okay, so that's how you do it. Alright, let's move on to question D. Question D, the vowels and the consonant, in alternate. Question D is here. The vowels and the consonant are alternate. Okay, so they're in an alternate place. Alright, so alternate place. So promise. Let's just have a look at the vowels and consonant. P R O M I S E. Alright, so firstly let's just identify the consonant and let's identify the vowels, right? So the vowels is O, I, and E. So O, I, and E. Now the consonant is the rest of the other letters, so we can have P, we can have R, we can have M, we can have S. Alright, so that's the only way you can alternate, you rearrange that, okay? Because you've got one less vowels comparing to the consonant. So the number of arrangements here is 4 factorial times by 3 factorials. Alright, so therefore the probability will be just 4 factorial times by 3 factorials divided by 7 factorials. And then we can use our calculator to work out the answer here. Alright, so the answer is 1 over 35. Okay, so that's how you do question D. Alright, now the vowels are together. Alright, so the vowels are together is actually pretty easy. So what we need to do is we group the O, I, and the E together. Alright, so for question E, we group the O, I, E together, so that's form one group. O, I, E, one group. And you've got the rest of the other letters, which is P, R, M, S. And those are separate groups as well. So in total, we will have 5 factorial ways times by 3 factorial ways of total arrangements, okay, when the vowels are actually grouped together. Alright, so therefore the final probability it will be 5 factorial times by 3 factorial divided by 7 factorial. Okay, so in this case, let's have a look what's the answer. Right, so in this case, the answer is 1 over 7. Alright, and that will be the chance. So as you can see here from this question 10, the questions are very similar to the previous question, but just this time they actually apply, or they actually incorporate a probability concept when it comes to, to a question like those. You're still dealing with the normal arrangement type of question, okay? But you only need to find out what is the total arrangement, so therefore you can actually find the probability. So within those total arrangements, how many words that start with R and S with those restrictions applied. Okay, so that's question 10. Let's move on to question 12. So I guess question 12 and question 10 are very similar. It's about just the words. This time they changed the word printer, and this time they changed different arrangement. Some of them looks very similar, like there are 3 letters in between, there are at least just 3 letters in between. So they're very, very similar type of question. Okay, so I'm just going to quickly do this one here. Okay, so firstly, printer, we find out what is the total arrangement here. Alright, so total arrangement, we count 1, 2, 3, 4, 5, 6, 7. So that's 7 factorial. Now you have to be very careful with the word printer. This time you've got 2 letters that are the same. So therefore we need to divide this by 2 factorial. Now this is a common mistake. All right, so make sure that you check the number of letters that that's repeating. And the answer for that is 2,420 arrangements in total. Okay, now let's calculate what's the probability with the given conditions here. The word start with the letter E. Okay, if the word start with the letter E, so E is fixed. The rest of the other 6 letters can be rearranged in any ways. So therefore, that's 6 factorial if E is fixed. All right, so the probability will be just 6 factorial divided by 2,420. Okay. The answer to that is 2 out of 7. All right, 2 out of 7. Oh, no. Okay, I made another mistake. Okay. Previous I just mentioned that, if the letters that are repeating themselves, make sure that you divide by 2. However, I forgot to divide by 2 factorials. Because within these 6 letters, you still have to double like R here, which means you have to divide by 2 factorials. Okay, so that's it's a bit tricky, and you just have to be very, very careful. All right. So that's 6 factorial divided by 2 factorials over 7 factorials divided by 2 factorials. So in the end, that just becomes 6 factorial over 7 factorial, which means that's 1 over 7. All right, question B. The letter I and P are next to another. Okay, so I and P are stayed together in a group, and the rest of the other letters are just like, we can rearrange it any way. That's 1, 2, 3, 4, 5. Okay, so in that case, you will have 6 factorial ways to rearrange it, but you times by 2 factorial, and then you divide by 2 factorial because of repeating digits. Okay, now you times by 2 factorial is because, let me think why you need to times by 2 factorial. You times 2 factorial because of that I and P can be switched around. Now you divide it by 2 factorial is because within one of the letter here, you have another letter P. So you've got double letter P here, so you still need to divide it by 2. Alright, so therefore overall, that gives you 6 factorial over 7 factorial over 2 factorial. Because remember the total arrangement is 7 factorial over 2 factorials. Okay, so the answer is, what's the answer for that? Okay, let's have a look. The answer for that is 2 out of 7. Yes, just because the difference between these two is divided by another 2 factorial, which if you times by 2 factorials to the top, you get 2 out of 7. All right, question C. There are 3 letters between N and T. Okay, 3 letters between N and T. Now, same thing. All right, so we just put N. Okay, let's just rearrange the others first. All right, so we've got 1, 2, 3, 4, 5. Okay, 5 letters. All right, so that's 5 factorials. Then we divide it by 2 factorials because within those 5 letters you will have double P's there. Then you can place the N and the T. Anyway, so if you place the N here, so you will have 1, 2, 3 places to place the T. Then you can keep moving the N, then you have 2 places, you have 1 places. And then at the end, you have to times by 2 factorials because you can switch between N and T. So let me just simplify this. If you cancel these 2 out, you end up with the denominator is still 7 factorials divided by 2 factorials, right? The numerator now, if you cancel the 2 factorials with the 2 factorials, you get 5 factorials times by 6. All right, so let's use the calculator. Okay, so the answer is 2 out of 7. Okay, and that will be the chance. All right, the last part, there are at least 3 letters between N and T. So this is the question we just did before. At least 3 letters, that means you can have more. Okay, wait a minute. I think, yeah, I think I made a mistake. I think I made a mistake again, okay? I think the question I did here is for at least 3 letters because as you can see, I'm actually having 3 letters here. Then if you place the T here, you will have 4 letters. So that question D, C I did is actually for question D. Now for question C, you can only have 3 letters, exactly 3 letters. So you can't have more than 3 letters. Okay, I didn't read the question carefully, sorry. So that's 5 factorial over 2 factorial when you're rearranging those 3. Then if I place n here, there's only one place that you can have t. Alright, so you times by 1 plus. Now if you place the n here, and there's only one place you can have t again. Alright, so if we'll keep going, okay, so that's the answer we should have, right? And that's the number of arrangements when n and t, there are 3 letters in between. So if we simplify this, that gives us a 3 times by 5 factorial. So the probability is 5 factorial times by 3 over 7 factorial, which is over 7 factorial over 2 factorials. Sorry, okay. Alright, so let's have a look. So as you can see here, it's really easy to make mistakes, alright, if you're not really careful. The answer is 1 over 7. Yep, I think that looks right now, okay? Just have to be very careful with the question. It's too easy, way too easy to make silly mistakes, like I did here. Alright, that's question 12. Okay, let's move on to question 18. So question 18 is a bit special because question 18 is all about just like, playing around with numbers. You need to understand about the divisibility rule. Obviously you need to know odd numbers, okay, alright, so let's start. A 3-digit number is formed from 1, 2, 3, 4, 5. 5 digits there. No repetition is allowed. And find the probability. So the first step we need to do is to find out the total numbers that's possible when you're selecting 3 numbers. And the order here is important. Because if you select 3, 2, 4, and 5, and that number is different to 5, 4, and 3. So the order is important. So again, the first step is the total possible numbers. Alright, so the total possible 3-digit, okay, number. What is that? That's 5 numbers, and we are going to select 3 numbers here. So that's 5p3, and the order is actually important. So 5p3, and that's 60. Alright, so in total of 60. Now we just need to look at the restriction, and we'll look at what's the chance. So the first one is actually really easy. The number 473. There's only one number that's 473. So the first question, it's 1 out of 60. Alright, a very easy question. Alright, so the next one is an odd number. Okay, so now with the odd number, what I need to do is, first you need to understand which number is the odd numbers here, and how do we make an odd number. To have an odd number, the last digit must be odd. It doesn't matter with the previous 2 digits. So then from this 3, 4, 5, 6, 7, we have 1, 2, 3. 3 numbers that's odd numbers there. Okay? So once you have these 3 numbers, I don't care about the other 2, the other 2 numbers. So once you have selected number, you have 4 numbers remaining, then you have another 3 numbers remaining here. Okay, so this is the total number of numbers that you can get that's odd numbers. So therefore the probability would be just equals to 4 times by 3 times by 3 over 60. Okay, so the answer is 3 over 5. Okay, all right, let's move on to question C. The number is divisible by 5. All right, again, if the number is divisible by 5, you can only have the last digit to be the 5. Okay, so that's the last digit has to be a 5, which means you only have 1 choices. Okay, so once you have selected 5, you can't select a 5 anymore. So you have 1, 2, 3, 4 numbers left, and then 3 numbers here. All right, so that's actually pretty easy. So therefore the probability is just equals to 4 times by 3 times by 1 over 60. All right, and then the chance is just going to be 12 over 60. That's 1 in 5 chances. All right, now the question D. The number is divisible by 3. Okay, now this is a bit difficult, okay, with divisible by 3. Okay, so Firstly, you need to think about if the number is divisible by 3, like how do we get what's the smallest number that's divisible by 3 when you select all of those numbers there, okay? All right, and then we need to find out the number combinations there. So if we just add these 3 numbers together, that's the smallest number you can add, right? So let's just try to see what's that. That's 7 plus 5, which is 12. Okay, so great. 12 is the smallest number that you can get that's divisible by 3 when you add all 3 digits together. Then what we can do is we can think about, what about 15? Can we have 15? And can we have an 18? Can we have an 18 to do that? All right, because it looks like an 18 is the largest that you can get. Okay, so these are the 3 options we have. Now, for the 12, we have already know, for the 12, you can have 3, 4, and 5 to get 12. Okay, what about 15? Now, to get 15, you need 4, 5, and a 6. And I think you also can do it with 3, 5, and 7. That's it. To get 18, which is the last 3 digits, 5, 6, and 7. So you have like 1, 2, 3, 4 ways to get it, right? But then within those 4 ways, you've got 3 numbers each. Then that's a 3 factorial, okay, within those 4 ways. Because we can rearrange these 3, 4, 5 into any orders, and they're still divisible by 3 here. So that's times by 3 factorial. All right, and then, so that's the total number of arrangements. But if you want to find the probability, so we're going to divide this number by 60. All right, so 3 factorial times by 4, and we divide it by 60, and that gives you the chance, 2 out of 5 chances. All right, so that's question D, divisible by 3. Okay, all right. I'll leave the next 6 questions for you to think about it. Okay, I just want to save a minute, for you to actually practice as many questions as possible. So I'll leave those 6 questions. But the idea behind it is very similar to the previous question. What you need to do is based on each of these restrictions here, and try to find out how many numbers that you can generate with these restrictions, and then you divide it by the total possible, numbers there, which is 60, and that becomes the probability. All right, so let's move on to the next one. And I think that's the last question I picked from this exercise. All right. So question 24. 5 diners in a restaurant choose randomly from a menu featuring 5 main courses. Find the probability that exactly one of the main courses are not chosen by any of the diners. Okay. This is a bit tricky now for this question. So firstly, let's find out the total possible arrangements for for the diners to actually choose the menus, right? So the total possible arrangement. Okay, now the question didn't say the diner have to choose different one. Okay, so you can choose like a main course A twice or 3 times. So therefore each person, so let's just draw some diagrams. So this is dishes, okay, these are just main courses, and those are just A, B, C, D, E. Okay, so we've got 5 different main courses, and now we have 5 different people. So 1, 2, 3, 4, 5. Okay, so I have 1, 2, 3, 4, and 5. I've got 5 people there. Now, each person will have 5 choices, right? I can choose A or B or C or D or E, and then same with this rest of the other people there. Alright, so each person will have 5 choices, and we've got 5 of them, so therefore that's 5 to the power of 5, which you can also do 5 times by 5 times by 5, and then keep going. 5 to the power of 5 is 3,125. Now these are the total possible arrangements, okay, without restriction. Now the question says, find the probability that exactly one of the main courses is not chosen by any of the diners. So imagine if this one is not chosen at all. So what's the probability of that? Okay, so let's have a look at this question. For example, okay, if this person number 1, start to choose. Here's the first one to pick. He will have 5 options to pick. Okay, 5. So therefore, that would be just 5. Okay, so if the first diner selected out of 5, well, that's out of 5, right? And then the second, choose a different one. Let's just say choose a different one, all right? Not choosing the same one, okay? Choose a different one. The reason for that is because if the second person is actually choosing the same one, then you will have more than one dishes that's not chosen by the diners, all right? But the question says exactly one of the main courses is not chosen. So therefore, each of them sort of like need to choose the different one until the last person, okay? So we'll talk about this a bit later. All right, so for the first person, all right, this first person will have 5 choices. Now for the second person, 4 choices. 1, 2, 3, 4. Okay. For the next one, 3 choices. Okay, hopefully that makes sense to everyone. So that's 1, 2, and 3. For the next one, you have 2 choices. That's still pretty obvious. 3 choices. So, okay. I'm just going to remove all of those. Right. This person will have 2 choices, which is the last 2. Now, for the person number 5, this is a bit tricky now. For person number 5, if the last person decides to choose, I should probably just do that. If the last person decides to choose, let's just say, for example, E, that means it's not exactly one of the main courses not chosen. Right? Everybody's choosing the main course. So this person is not going to choose that, all right? This person is not going to choose the last one. So the last person has to choose from the previous 4. So imagine if number 1 choose the first, number 2 choose the B, number 3 choose C, number 4 choose D, then the last one is not going to choose E. Okay, we need to make sure that E is not chosen. Okay, so therefore to satisfy the question, exactly one of the main courses is not chosen by any of the diner. So therefore this number 5, this person has to choose out of 4. Okay, so therefore we need to times by 4 here. Alright, so now if you look at this, this is the number of arrangements when this dishes is not chosen, number E is not chosen. But we can actually repeat that for every dishes, okay? So if we repeat that for every dishes, we times by 5. Alright, we can we can have number dishes number D is not chosen. We can have like main course number C is not, letter C is not chosen. So we times by 5. Okay. But then, one meal is repeated, right? Only one, one of the meal is actually repeated. So therefore, 2 diners will have the same meal. Okay, think about it, all right? So one of the meal is not going to repeat it. So this number 5 here, maybe is going to choose A twice. So if we have one meal that's repeated, we need to divide it by 2 factorials. So divided by 2 factorials. This is the total possible arrangement when we apply these the restrictions, which is 5 times by 4 times by 3 times by 2 times by 4 times by 5, and then we divide it by 2. That's 1,200, and that is equal to 1,200. If we want to find a probability, it will be 1,200 divided by 3,125. Okay, so therefore that gives us 48 over 125. All right, so that's what we're going to get. Now, very interesting question. All right, so now question B. Repeat this question if there are n diners with n choices. Okay, so that's very similar. Okay, very, very similar. N diners with n choices. So therefore, this time we still find out what's the total possible arrangement. That goes to n to the power of n this time. All right. And then if we just look at the pattern from the previous question, we should be able to do the question very easily. Now, the first person will have n choices. The second one will have n minus 1 choices, n minus 2 choices, and goes on. The last person here is the same. Have a look, is the same as this one. So therefore, the last one, if you keep timesing it, it's n minus 1 again. So let's just put a square bracket. And then we need to times by, previously we times by 5 because we've got 5 dishes, right? But this time, like, we times by the total, which is just n. So if we just follow the pattern from the previous question, we can solve it like really, really easily. Alright, so once this is done, we divide it by 2 dishes that's going to be repeated. We divide it by 2 factorials. And then all of these will be over n to the power of n. Okay, sorry about this very long, fractions here, but we can actually simplify this. Alright, let's have a look. How do we simplify that? Firstly, if we times these 2 together, that gives us n to the power of 2. And then if we times this together, that should give us n minus 1 to the power of 2. And then the rest of them is n minus 2 factorial. And finally, we can move this one down. That becomes 2 factorial times by n to the power of n. So that would be the expression to calculate what is the probability that, if we have n diners and a choices of n main courses. All right. Hopefully you enjoyed this question here. It's a pretty interesting question. That's the reason I picked the question here. The rest of the other question, like question 18, are pretty standard. As long as you actually know how to do the restriction type of question, the rest of them should be quite easy. All right. Let me know how if you find any mistake in this video. All right. Thanks for watching. Thank you.